Hello and welcome back to Combinations, Part 3. I've got a really fun example here, and this has to do with cards. Yeah, it reads, in a regular deck of cards, and that's 52 cards, how many ways are there to form a full house? Now, if you don't know what a full house is, it means that you have one pair, so like maybe a pair of aces, and then you have three of a kind, so maybe three jacks or something like that. So the question is, how many different ways can we build a full house? So we want to arrange 5 cards. We don't care about the order of the cards, but what we got to have is we got to have one pair and we got to have 3 of a kind. Now, what makes this question tricky is that you have to use the combination stuff because the order doesn't matter. But you also have to do it within sort of the fundamental counting principle approach. So it's kind of like we start off and we say, all right, if we are using fundamental counting, one of the first things that we would decide is how many choices are there for pairs. So we'd say, well, it could be a pair of 2s or 3s or 4s or 5s or 6s, blah, 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 all the way up to a pair of aces. So there are 13 choices, okay, for the pair. So you go, yep, okay. So I made for the pair, I have 13 choices. Okay. Now the next thing we have to do is how many ways are there to form a pair? Well, if let's say we're talking aces, well, you have 4 aces in the deck. So here you would have 4. Choose 2 of them, okay? Because it could be an ace of spades and an ace of clubs, but it could be an ace of spades and an ace of diamonds. You know, like what we're talking about is of the 4 aces, you want to choose any 2. It doesn't matter whether it's aces clubs or clubs aces. That's why we're using choose. Okay, this is how many different groups I can make of aces. So now, again, it doesn't have to be aces because there's 13 choices, right? Now, that's for the pair. Now, the 3 of a kind. Okay, how many different types of 3 of a kind are there? Well, normally there would be 13, but they can't be the same as what you picked over here for the pair. In other words, like let's say I picked aces. I can't use aces again. I can't say, oh, I got a pair of aces and 3 aces. Okay, that doesn't work. So you only get 12 choices. Okay, and now how many groups can I make? How many groups of 3 of a kind? Well, you have 4 cards, and this time you're choosing 3. And there it is. This is what, if I multiply all this stuff together, this is how many different ways I can make a full house. So some of you, I'm sure, have played some poker, and you're probably curious. I wonder how many full houses exist. Well, there are 3,744 different full houses possible with a deck of 52 cards. All right. There's one more thing that I want to show you before I stop with talking about combinations. Okay, so I'm going to clear the screen. I'm going to show you an interesting thing here. If I take the formula for n choose r, and it looks like this. N factorial over n minus r factorial times r factorial. Okay, so I'm going to leave that on the back burner for a moment. Now I'm going to look at this. What if I had n, and then I had choose n minus r? Okay, and what would that look like in my formula? Okay, well, on the top I would have n factorial. Then I would have n minus r, all factorial. And then over here I would have n minus r factorial. Okay, now there's a bit of cleanup that I can do on the right side here. Okay, I have my n factorial. Then over here there's not much I can do about n minus r factorial. But look at this. I have n minus n. That wipes out. and then I have a positive r. So this is actually just r factorial. Now have a look at this and have a look at this. I think I see the same thing. In other words, this here turns out to give me the same number as this here. And let me just show you what that looks like with actual numbers, because probably you're thinking, well, what does that really mean? It means if you had something like 12 choose 5, okay, that would be the same thing as 12 choose, and then n minus r, 12 minus 5 is 7. Okay? So 12 choose 5, I should get the same number as 12 choose 7. Or similarly, if I had 20 choose 3, that would be exactly the same thing as 20 choose 17. Okay? Now that's a little bit of an important concept. It'll be important later on. Now I'm going to stop, so we'll catch you later.